Welcome, students. Welcome. Good afternoon. My name is Patricia Bejarano Vera. I'm the Project Lograr coordinator, and this is wonderful to see all of you signing in to our Zoom workshop today. Our presenter is Dr. Karsten Lenke, and he'll be signing on in just a moment. So just want to greet you and say thank you for being here.
Hello, welcome everybody, and I would like to start with a message that I'm just reading off the screen here. From Albert, he says, "Hello, amazing team. I'm so excited for today's workshop," and I can really want to agree to that. And it's Patricia Bejanaro and Salomon Aldak who put the most work in this series, and there are so many good talks. So this is the second talk in a series of art talks, and I try to find a compromise to make it possible that everybody who just jumps in this time and is a total beginner can follow, and that I have also something new for people who did the last one. I introduce R. R is a statistical programming language. Together with RStudio, it became extremely powerful, and here are four reasons to use it. R is a quasi-standard for statistical computing, together with Python. R is free, R is easy to use, and what you will see today, what most people probably don't know, reporting results with R, to use it like a word program, is very easy and is very impressive regarding the output results. Here is the first workshop versus the second workshop. In the first workshop, I talked intensively about how to install R, how to install RStudio, and a few tips and tricks. And if you like, you can watch the first workshop on this sheet here, what I provide, and you will also find information on that sheet with a little bit delay from a few days, including the recording of this workshop, and you just have to click here. And I will also email that link to you. What we do in the first part is we talk about R and the tidyverse and the Tidymodels. The tidyverse is a package of R that gives R more functionality and is almost the standard for data scientists. Tidymodels is a very convenient package that makes data analysis way easier and is not that popular than the tidyverse. We will use these packages for cleaning data, for data visualization, and we do a very basic data analysis. Then in the second part of the talk, I will take this analysis, the one that we did, and integrate it into a little booklet, and you will see that you can easily make a complete book, a thesis, or an article out of it. I'm actually doing that. That's how I found it. I use it for machine learning book, and I will use entirely RStudio to develop that machine learning book. So let's start with analysis. The analysis is based on data from a textbook, the Woolrich textbook. It's a relatively famous data set from 1976. And our goal is to find out, do we have gender wage discrimination in 1976? And what makes this analysis easy is we know, of course, there was gender wage discrimination in 1976. But we want to analyze it in a decent way and show it in a decent way. So here are my data. I put them in an Excel sheet. Here's the Excel sheet, or Excel workbook. These were the original data. I cleaned the data a little bit. So we have wage, education, experience, job experience, tenure. Then we have a variable that says if the record is a record from a white person, then it is yes, or from a non-white person, that would be a person of color, then it's no. Most important variable, of course, female and male. These three variables we will not even use. What you can see here, I sabotaged the data set a little bit. I just deleted some information to make it not that perfect, because in reality, data sets are never perfect. There is one entry missing here with education, one for tenure, one for the race variable. We call it a dummy variable because it's only yes or no, and several records for the dummy variable sex here and here. I also, just to show how much more powerful R is, I generated a chart, just quick, without a lot of effort in Excel. But what's the result without a lot of effort? Well, the chart has no axis title. The title of the chart is actually the axis title from the vertical axis. And as you can see, because our data here, because wages left, and that always becomes the x-axis, the axes are exchanged. I would have to all fix this in Excel. I don't do that because I just simply import my data. So before I do that, I want to talk about the windows of RStudio. So there is R. This R is the power of the program. It is the actual software that does the calculation. And on top of R, to make it more user-friendly, we have a program that is called RStudio. RStudio has 4 windows. The 2 right windows are mostly information windows. They're very powerful, but they are not needed to operate the system, but they provide a lot of information. The power is here in the lower left window. This is our actual R programming language. I can assign variables, a equals 2, hit return, b equals 3, hit return, and then I can say a plus b equals 5. Our variables are way more powerful. Normally, variables hold only numbers or maybe matrix. Our variables hold tables. Our variables can hold graphs, plots, and of course, they can also hold numbers. We will see that in a moment. What happens in the left window? In the left window, we usually have a script here, and I prepared one already. And what does it mean, a script? It is very important to know in R that a script is nothing else than a simple text file. There is no logic behind here. There is no power behind here. It is a text file like a TXT file, a notepad file. What is the advantage? Well, the advantage is that we save our code here. I can save the text file and I don't have to retype the code. So I prepared here and I don't have to type all this code. And what happens is, and I can show that to you in an easy example. If I type here A times B, and if I hit Control Return or simply this Run button, then A times B gets copied down here and gets executed. Look, I click, copy it down here, and A times B gets executed. The result is 6. I don't want that, so I delete this here. What I do want is, I want to make R a little bit smarter. R is very lean when it starts, and you would only load the functionality that you really need. And this functionality is saved in packages. So one of these packages is called the Tidymodels. There's excellent literature for that. I load it here. Takes a moment. Tidymodels we talked about already. Then there is SkimR package that allows you to show and analyze your data just with one command. We'll use that. And then last but not least, we need the read Excel package that makes it possible to read from our Excel data. I could do this here by just clicking it from Excel, but I copied the code and there is a short section and even a link how to do that in the learning guide where I gave you the link for. So I copied the code here and it loads my data. If I want to know how many records I have, because this data is just a table, I just ask, how many rows does my table have? And I assign that into a variable so I can use it later on. I call it n original data, n-org. Execute it, and you can see here in the right window where I get some information, n-org is 526. You can ignore the letter L there. So we have 526 records. What you also see is that my whole R script is organized in different sections. I did that. And a section always starts with 2 pound signs and the word knit-r, and then the section name. Why do I do that? I do that because later on, when I will report about my results, then I can refer to these sections. I could, for example, say, give me the listing, give me the code that is in this section, execute this section, make everything what is in this section available to me in my book. That's why I have the section. So the first one is called setup. Second one is called summarize. And here's where I use my skim package. And what you also see is I could have done it like this. Just execute the command. And then I get all the information here, down here. Instead, what I did was I assigned the results of this command. It's always R is always a command name, open parenthesis, and then some parameters, in this case, just my data set. And the results go in another variable, I call it data info. The reason I do that, first of all, it looks a little bit better. You can see it here. See, here is the short analysis, and we can see the race variable is missing 1 record. The sex variable is missing 3 records, education 2, and tenure 2. So I have to do something about it. The other reason I do that is because some of this information I want to later on use in my article or in my book, and I don't have to type the command. I can just read the variable. But let's forget about it for now. Let's clean our data. Cleaning data was always possible in R, but it was a real pain. And the code was very cryptic until the Tidymodels package was invented or published. I think it's only 2 or 3 years ago. It's a relatively new package. And in R, some people have humor, and in that case, they do have humor. They use cooking terms here. So to clean our data, we use a recipe. And the recipe, like every recipe, has several steps. And the steps are separated with this. It's called the piping operator, which basically says, do this first, then this, then this, then this, and so on. If I don't do this here, I create just a recipe. A recipe starts always with the word recipe. And then it has the data that I want to use, that I want to clean or manipulate or do data engineering with. And the variables I like to use, which is wage, education, experience, tenure, non-white, and sex. They are connected with pluses. So see the plus as an and, like an ampersand more rather than a plus in the arithmetic thing. And the first one is separated here with a tilde. That means this will be my dependent variable. So I put everything together. After I get the data I want in there, I have to consider, I don't know if you remember, but non-white was coded as no and yes. No programming language can deal with that. We need what is called a dummy variable that is coded as 0 for non-white, for white, and 1 for non-white. So I could do that, and I would need a lot of code to do that. Here, I just use the step. It's always starting with the word step, and then what it does. Make the variables dummy variables. And I don't even have to name the variables. I don't have to say non-white and sex. These are the two ones I want to use. I can say all nominal variables. Okay. Remember, education was a numerical variable, how many years of education you had. And there were holes in that variable. So what I can use here, I can use something to fill these holes, and that's called imputation. And with what I want to fill it is, I want to do the least damage. So instead of just making up a value, I take the mean of all other values. Well, if I would do the same thing for the variable non-white, then I would put something in there of 0.3, 0.7. That makes no sense. It's a dummy variable. Non-white is 1 if it is a person of color. By the way, that is shown here with a yes. And is 0 if it's not. 0.2, 0.3 makes no sense. So what I do here, instead of using the mean, I use the median. Simply the variable, either 1 or 0, that appears most. Tenure, I could use the mean, but just to show you that there is a way more powerful imputation process, I use k nearest neighbors, which is a machine learning procedure. Basically, what it does is it finds a certain number of records that are similar to the damaged one, and then take the average only out of these few records. And then last but not least, remember, we're doing gender discrimination. So I don't feel comfortable because sex is such an important variable in this analysis. I don't feel comfortable with using the median or using KNN impute. What I do instead, I just say I have enough variables. Wherever that sex variable is missing in these 3 cases, it's thrown out. R, when it created the dummy variable, already coded in a way that if it's a male, then it is 1, and it renamed the variable to show me that. Okay, so this is a recipe here. And see it as a recipe that is in a book. It's just booked. You haven't prepared the meal. So at the end, you add the command prep, and that actually runs the recipe. I do that. The recipe is done, is executed. The new data are somewhere hidden in my recipe here. So what I do here is I juice, again, cooking term. I squeeze the data out of my recipe. I called it recipe CL. I think it's good practice if you generate your own variables and they're similar to standard variables. I like to add my initials so I know I generated this variable here. So I run it, and we can look at the data here. And you see the data don't have any holes anymore. Okay. What we need later on, we need to know how many records we have in our wage data. So we assign that to the variable n, and you can see now we have 523 and not 526 because we threw some out. Okay, I want to show you a little bit of data visualization here. I use a scatter plot, and there are many ways you can visualize your data. I believe, and many others do too, that ggplot is the best way to do that. It needs a little bit to get used to it, but at least I want to show you the logic. you can already see that it again comes out of different component here. I just want to focus on the first component. So it is a command ggplot. It has the command data equals wage data. Of course, our diagram has to know where the data are coming from. And then he has this AES command. I recommend what is not even correct. Understand it like this: axis. In reality, it doesn't mean axis, it means aesthetics, which is very misleading. If you want to understand it, interpret it like axis, but you have to, of course, write AES. And it says which variable goes on the x-axis and which variable goes on the y-axis. And if I run this command here, you will see nothing. Why do you see nothing? Is two reasons. First, I assigned the result to a variable rather than outputting it. I can fix that. I just type the variable, scat plot, and then I get this one here, an empty diagram. But that is already a lot because the scale is already correct for the data. The axes are already labeled. It's just nothing in there. Well, I can fill up the diagram step by step. At the end of the line, I have a plus and I have a new command here. Every type of diagram starts with the word geom, underline, and then what I want, point. And that's it. And I also want to add a title. And if I execute my command here, you will see that now my diagram has the data in it, and you can already see with increasing education, the wage goes up, which shouldn't be a surprise. If I want to add more, I don't have to start from scratch. I can say my new scatter plot is my old scatter plot plus geom smooth, which is nothing else than a smoothed line through the data. And in this case, I want to simply use a regression. So I use linear model LM. If I execute this, you can see here is a line, and it confirms what we are expecting. With higher education, we get a higher wage. So I can use other plots. I can make a box plot. The x-axis is, in this case here, my dummy variable. So I get two box plots, one for male and one for female, and the vertical axis is wage. I create my box plot, and like before, I add the title. And I save that, try to remember that, in the variable box plot. You don't have to do that, but we have to do it because we want to use it later on. So if I type box plot, here's my box plot, and we can already see here the ones, the males, have a higher mean wage than the females. Maybe I want a histogram. Histogram is special because it has only an x-axis, because the vertical axis would be the count. So I say here only x-axis is wage, and the data come from my data org. They shouldn't come, they should come from here, from my wage data. And I say I want a histogram, I add a little bit color, and I give it a title. Here we are. You can look at it. Histogram. And here we are. And we can see it is skewed to the right. So we have on the right-hand side, we have more outliers with high wage than we have outliers with low wage, which is very typical for data. So back to our problem. We want to see if there is gender wage discrimination. And what we could do, we could run a t-test that just compares the two means and sees if they're significantly different. The problem with t-test is that we can only apply it if at least the variances of both groups are the same. There's a test for that. I run it here, and this time I don't push it in a variable, so I get the output in the console, and we can see the true ratio of variance is not equal to 1, so we cannot assume that the variances are the same. Well, what I can do then, I can simply add a parameter here and say variance equals is false, execute my t-test, and then it runs, instead of a simple t-test, it runs a test that is called the Welch two-sample t-test, and I can see the results here. The mean of man for wage is about $7. The mean for women is $4.50. Well, we kind of knew that before. But is this just by accident or is it systematic? Well, with the chance of 99.999%, we can rule out that this happened by accident. So there seems to be wage discrimination. But wait a moment. Maybe that is not related to sex. Maybe it's related to education. So this is not enough to run the t-test. So we run a short regression. And I run it here. I run 2, but I show you only the last one. And what I do is very simple. LM means I want to have a linear model. Then I say where my variables are coming from. They come from wage data. And now I have to say wage is my dependent variable. And here comes the tilde. And then I would have to type an endless list of variables. But I don't have to do that because I can simply put this little dot here. That means use all variables. But if you look at the results from the previous one, you will see that the race variable is actually not significant statistically. So we don't want it. So I just say minus. And again, that doesn't mean minus in the arithmetic sense. It means just don't consider the race variable. I run it. And again, I don't get any result because the result goes here in my variable. But I can take a look. Summary is a command that I can use. Where do I have my results? In the variable model LM final. I don't have to type it. I can autocomplete it. That also avoids typing errors. And here we are. And what we can see, all my variables are significant. So chances that one of these coefficients here is 0 is almost 0, the probability. And we can see wage increases with education, with experience, and with tenure. And if the sex variable is 1, which means male, the wage increases by $1.80. Now I can clearly say, hey, there is wage discrimination. I would have to do a few more tests, but this is already a pretty clear picture. And at this point, I want to stop with my data analysis. So what if I want to write a paper, a book, or a short report about these analyses? What can I do? Normally, you would have to copy and paste the code into Word. Then you would have to take these pictures here or these diagrams. Yes, you can export them as a PNG file, and then you can copy and paste it into Word. You can blow them up. And every time you change something here in your code, you have to do it all over again. And that is very ineffective. So we don't want to do that. What I do instead, I use a package that is made for writing books, but you can easily write smaller. You can write a report, or you can write a report, or you can write a paper, and that is called BookDown. And what I have to do is I have to install these packages. And you only have to do that once. And it's only 4 commands. So it's not a big installation where you have to shift this and this file. So first thing you have to do is you have to install the package itself. Install packages. And the package is called BookDown. Here it is. And I click install package. I don't do that because I have it installed already. The second package that you need is the package TinyTag. What our BookDown does, it generates a beautiful HTML page, and it also generates a PDF file that is visually very appealing and formatted almost like our library wants it. So it's very convenient for students to do their thesis with it. You make a few adjustments and that's it. What you need for that is tech or LaTeX. And whoever worked with LaTeX before knows it's a great program, but it's a real pain to install. If you don't have LaTeX, there is a way to install it within 5 minutes and no hiccups. So what you need for that is you have to install another package, and you have to do that only once. It's called TinyTag. Here it is. And you install that package. Again, I don't want to do it because I have it already installed. And then 2 more steps. You load the tiny package, and you load the package with the word library. You can do that in the console. TinyTag. And you don't have to take notes because you will get the video and you can do it step by step. Execute it. I will not execute it because I used a different package and I don't want to override it. But TinyTag just works fine and it's just enough. And then last step, after you have the package loaded, you say install underline TinyTag, open parenthesis, close parenthesis. You click enter and your TinyTag is installed and you're ready, you're almost ready to roll. One more thing you want to do is you want to download a sample project. And I've done that here already. You download a zip file, which is basically a folder. You expand that file on your computer and you have a folder with a sample project. Then the only thing what you have to do, and that is super important, you say file, open project, not open script, open project, and you navigate to wherever you unpacked this folder. Here it is, BookDown Demo Master. And there you find an R project file and you just open it. Consequence is that now your R goes to the correct directory where we have a bunch of files, and we don't even care for that now. We will talk a little bit about it later because you're done already. I go to the build button and I can build here HTML, PDF, or a kind of Kindle format that doesn't work so well. These ones are the 2 ones I would actually suggest. So let's build the HTML because it goes fastest. I haven't done anything. I just downloaded the folder and executed it. And here is not my book. It is a book from Yi Chi. It's a short one with some examples, some graphs. So why does that help you? Well, it helps you because you can use this book as a template to do your own one. And before we do that, just one hint. And again, I suggest you do exactly what I showed you. You install the TinyTag. But if you have the big LaTeX installed already, you want to open this file here. And then here, it said something else before. You just put PDF LaTeX in there. That's all you have to do. I had to do that because I work with a different LaTeX version, but it works with TinyTick quite well. So you have a lot of other files here. And what you can see here is there's introduction, a literature, and so on and so on. I will go, when I edit it, I made a few edits already, otherwise it would just take too long. So I close this here. And I go to the project that I have already edited. And I will show you what are the changes that I made. I made very, very few changes here. These are the original files. And what is important to know, the files where your book lives in are the files that end with RMD. And some of my files here are almost empty. Look at just the chapter. Each chapter gets its own file. So the summary chapter gets the title, final words. Every title starts with £1, the subtitle with £2, and then the text that I want to write. So I have something for chapter 2, 3, 4, 5, and 6 is where my references go. Well, where's chapter 1? Chapter 1 lives in its own file, and that file is called index RMD. Also an RMD, just has a different name. We will take a look at it later on, actually in a minute. Why do we number our files? Well, we number them because the order they are numbered, this will be the order they appear in our book. And of course, I want to appear chapter 2 first, chapter 3 second, and so on and so on. So chapter 1 is our index file, and that index file has a header, has a little bit more information, and I didn't change it here. This is the original index file from the template. You see the author, a minimal book example. So what do I want to change? Well, of course, I want to have my own title, and I'm a terrible typer. So I just copy and paste it here. Of course, I want my name here. And that's it. And then here it says prerequisites. This is from the template. I don't want this stuff, so I just delete it here. I'm done. And then what comes here is my own code. And again, to save some time, I prepared it already, and I will explain it. So the chapter title always starts with a £. And I call my chapter introduction. And then here is something very special. It's called a chunk. And the chunk is where I can work with my R code. See, I read the R file. The R file we worked on before, I read it into my chunk. How do I create a chunk? It always starts with 3 backticks, but I don't have to do that. See, here's this little chunk symbol. Here's my chunk. Then it has settings, and I can say what the chunk should do, and I don't go with the document defaults. In that case, I don't want that anybody sees that in my text. I just want to run the code. Show nothing, run code. See, include false. Same then in the upper chunk. I did that already. So I load the library here. You always have to do that. Library init R, that has to be always there if you want to use your R code. And I read my file. And nobody has to see that in my book. Now comes my text. This book is not about math. However, everybody knows this formula, and I want the Pythagoras formula here. And I want it nicely formatted, and I want it with a number. And the only thing what I have to do is I have to use begin equation before the formula and end equation after the formula. A few things you have to remember, but what I'm showing you here, I think covers probably 90% or more of what you will ever use. So I begin the equation here, I end the equation here, and here's my equation. C to the power of 2 equals A to the power of 2 plus B to the power of 2. A little ugly, but I can read it and we will see it looks way better. If I want it numbered, I use parentheses because my number will be in parentheses later on. A backslash, a pound, EQ, and a colon. This is something you want to have on a cheat sheet. And then this one here, I made it up, Pyth, like Pythagoras. And that does not only generate a number, I can refer to this number. Let's say this number is equation 2.1. I can say here, equation 2.1 is this and this and this. So I do this here. It is a backslash, and in this case, it's an @ sign, ref, and then equation, and then my command. I can do the same thing with figures and with tables. And this equation is very important, and very important should be boldface. How do I do boldface? Just 2 stars, beginning and end. And if I want something not boldface, but if I want to have it in italic, I would choose just with 1 star. But I want to have it boldface. What if I want a formula inside my text? An inline formula. Start with $, end with $. And eventually you have to calculate the square root out of c square. So sqrt is a command for square root. LaTeX commands always start with a backslash. C to the power of 2. And it conveniently shows me already how it looks like, so I can see if I did something wrong. But as I said, the book is not about math, it is about tips and tricks of R. So I have the topics I want to cover here. This is my first topic. I want to have an enumeration. This is my second topic. These one are subtopics. So I indent them a little bit. That's all I need to do. Doesn't look beautiful originally, but you will see it looks beautiful when I create my HTML. And it is as easy, if not easier, to type as Word. And if I later on want to add something, no problem. This one I want to have in italic. So it goes in single stars. And now comes something is I want a link. How do I write a link? Very, very easy. We don't have to type HTML code, the A tag and everything. In brackets goes the text we want for the link. And directly after it, in parentheses, goes the actual link. And it will just look fine. What if I want to sign literature? Well, if I want to sign literature, what is important, I have to have the literature somewhere, and I have it here somewhere in this file, BookBib. That's where I write my literature. And just as a side note, there is a program, it's called JabRef. I will put it in the notes that can write it for you very conveniently. You don't have to edit it manually, but I did it manually. And we have this great book, what I really strongly recommend, from Yi Chi about our Markdown. And the best thing, it's free if you click on this link. And then, modest as I am, I added 2 of my own books. They are not relevant at all for what we're doing here. What I want you to focus on Each book has a label. I call this one here Lang Seniorage. I call this one Lang Neural Nets. And I call this one here G 2015. And I can refer to these books in the text. This is actually, the text is wrong. It can be found. This is about the book. The book can be found here. And then this material for this talk. Click here. And now I can add my book. A book that is not at all related to R can be found here. And the only thing what I do is I put in brackets the shortcut, the label for my book, together with the @ sign. That's all I have to do. I'm done. So now I can see my first chapter. I go to build, and I built it in HTML. Save selected. And if I didn't make a typo, our HTML should come up. It takes a moment. And you can see it runs a code that we used before. And here we are. It comes in kind of a pseudo browser. I would always recommend to open it in your own browser. Looks nicer. Here we are. Look, there's a nice outline. Here's what we did. Equation 1.1. It refers to equation 1.1. This is boldface. This is our enumeration. Looks way nicer. Here's our material for the talk. If I click here, the learning guide opens. And let's stick with this browser here. If I click on the literature link, it goes to the references. And what you see here, what is interesting, remember I put 2 of my books here, but only 1 book shows up. Automatically, the system only puts things in the references that are actually cited in the text, and that's what we want. So I go back to my introduction, close my browser, and I go briefly to the other chapters. We don't have too much time, so I do it fast. We go to the visualization chapter. Here it is. What I do here is, this is important. I created this one here. I want to only show the output. I tell the system, execute the section visualization. And now I want to include a graphic. That's an R logo. I have it on my hard drive. And I don't want it very big. I want it only to take 20% of the space. Then I have my scatter plot. And I name my section here. You can name it whatever you want. I just named it scatter plot. And I can refer to it as figure scatter plot. And in that case, again, I just only want to show the output and not the code. And then it plots my scatter plot. It does the same with the box plot and the histogram. If I execute the code, and this time I will execute the BookDown code, the PDF file. Then I get an error message. That is evil. I hope I can find it. Yes. Usual stupid error. An unexpected incomplete string. Scatter started here, and it says somewhere even, did you forget? And I did, to close the string here. Close it, run it again. And it generates a PDF file for me. And you will see something interesting in the PDF file, because if you have a figure in Word, the figure goes where you put it, if it is an ugly spot or not. This system here puts, at least when it's PDF, where we have pages, it puts it in a reasonable place. It's still working. And here we are. A nice title page. Here is my data processing section. I didn't comment on it, but in one point I just want to say the list, see the listing. It shows it here. It shows the tables. In this case, I said I only want to see the first 10 records of the original data, which has holes, and the finalized data. And now I come to my visualization. Here's my R symbol. And then what you would expect, that here a scatter plot, figure 3.2 shows the scatter plot. You would expect the scatter plot to be here. But you can imagine that there is not enough space for the scatter plot. So we would have a page break, and that would be very ugly. And what the system does automatically, and if you don't like it, you can stop it doing it, but I wanted to show it to you. It writes a text, and if I click here, figure 3.2, it goes to figure 3.2. Here it is on the next page together with figure 3.1. And this is a little bit extreme here because I don't have a lot of text, but if I have more text, it is no problem. And you can see everything is perfectly formatted. You don't have to use your mouse to scratch the diagrams or not. They automatically fit exactly. If you don't use anything else, they automatically fit the text width. And then here, my regression results, I created them in chapter 4. And again, it has the listing here for the regression and the regression results. And my references, my final words here. Remember that almost empty file, not too impressive. What I want to get your focus on is the bibliography, because I chose, our standard is APA style, or it's called APA-like style. And look at this here. Dynamic documents automatically formatted in italics. I don't have to do that. The system takes care of it. I just have to provide the information, and the system takes care of the formatting. I don't have to take care of the order. Everything gets automatically alphabetically ordered. So we reach the time limit. We have our report. One thing I want to show you is the HTML report. So I generate that one. Because it has a lot of built-in functionality that just comes with it, and I didn't even show it to you. Takes a moment. When this cryptic text comes up, it's always a good sign. Yep. And again, we open it in a real browser, not in a pseudo browser. Here we are. And here's my text again. Nothing new. I don't have to show you. We have our scatter plots here and everything. Okay, but what I want to show you is, go to the introduction here again. This functionality comes automatically with it. Look, the title is nicely formatted here. I can download the HTML here. And I especially like this one here. I can change the font. If I like a serif font better, then I can change it. I like the sans serif better, so I leave it. I can, if I need glasses, and I do, I can have it a little bit bigger. And what I especially like, because I read a lot at night, I can switch it to night mode. This is way better if you read at night and it's dark. And then there's this mode here, which is apparently the best for the eyes. I think it's an insult for visualization, but according to some research, this is the best for the result for the eyes. I have a hamburger menu here. If I click it, then all the functions go away. My text gets bigger. If I want my outline back, I can just click it. If you want to program something like that in HTML, it would be so much work. And it comes as it is. As a technical note, if you want to change things, there is, and that's more for LaTeX experts, there is a preamble file where you can change the LaTeX, and there's a CSS file where you can change how the HTML looks like. I would recommend do minor changes because you want to focus on your content and not on the outlook. I want to end it here. Again, I will send you the link for the learning guide, which has all the information you need about that talk, including the recording. Thank you to the organizer, but especially thank you for the audience. I was very happy that we had so many people.